Alright, in this video we're going to be looking at circles, and to get a kind of an idea of where the formula for a circle comes out from, we're going to first look at the Pythagorean Theorem, which states that if you have a right triangle with legs of length A and length B and a hypotenuse of length C, the Pythagorean Theorem says the sum of the squares of the legs is equal to the square of the hypotenuse, or A squared plus B squared is equal to C squared. If we draw our xy plane and we pick a point over here which we'll call x1, y1, and another point x2, y2, if we draw a base, we're going to draw a triangle here, and that length of that base right there is going to be the difference between x2 and x1 in absolute value. Since x2 is further to the right, this length will be x2 minus x1. In a similar fashion, we'll go ahead and find the length of the height here, right there, and we'll call that y2 minus y1. We'll go ahead and connect the 2 points here, and that is going to be the length of that line segment connecting those 2 points is going to be the distance. Okay, so we do have a right triangle here, and so it's going to be the a squared. A is going to be the length of x2 minus x1, so x2 minus x1 squared, plus the b, which is going to be y2 minus y1 squared, and that's going to be equal to the distance of d squared. And this is actually what we're going to use for the equation of the circle, but if we want to go ahead and derive the distance formula, we'll go ahead and take the square root of both sides, and we'll have the distance formula, which states that the distance is equal to, and let's write this all in, so the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So let's continue on, and we'll get to the equation of a circle. And we state that a circle centered at h, k of radius r is defined to be the set of all points x, y in the xy plane such that the distance from the point xy to hk, or from the point hk to xy, is equal to r. And then from that we get our standard form for the equation of a circle, which is x minus h squared plus y minus k squared, and that's going to be equal to r squared. So we're going to do a couple examples where we're given the equation, we'll come up with a formula, maybe we're given the formula, we come up with what the center and the radius is, and maybe do a little bit of graphing too. So the first question here says to find the equation of the circle centered at -4, 5, and with a radius equal to 11. Okay, so our standard form of equation of a circle, x minus h squared plus y minus k squared is equal to r squared. The center is hk, so the center is -4 and 5, so that's your hk. So x minus the h, which is -4, so you got to be a little bit careful there. There's a negative sign that comes with the formula. Quantity squared plus y minus the 5 quantity squared, and that's going to be equal to 11 squared. So that gives us x plus 4 squared plus y minus 5 squared, and that's going to be equal to 121. And that's the equation of our circle. Maybe we'll go ahead and practice graphing this. So we're going to rewrite the formula again, or the equation. Okay, so the center is going to be -4 and 5, so we'll go left -4 and up 5. So there's our center. And then our radius is 11. So from the center, we'll go up 11, we'll go left 11, we'll go down 11, and we'll go right 11. And that'll give us a couple of points to kind of try to graph this. So I think I go up and down first, so let's see what happens. So we're going to go up 11. So 5 plus 11 is 16. And 5 minus 11 should be negative 6. Okay, so that's the up and the down. And now we're going to add 11 to the minus 4. So negative 4 plus 11 should be 7. And negative 4 minus 11 would be negative 15. And so we're just adding and subtracting 11 to both the x and the y coordinates of the center, and that gives us these 4 points around the center here. And then you do your best to graph a circle. So we'll go ahead and graph our circle there through those 4 points roughly. It doesn't go through the circle, that's where it's centered at. So any point, so if we pick this point right here, this distance here is going to be the same as this distance over here, which is going to be the same as this distance over here. Doesn't matter, as long as we're taking a point on the circle. Okay, let's move on and do another example. So I think we're going to have the same instructions. So we're going to find the equation of the circle centered at negative 2, 7 with a radius of, I think it's 2 over 5. It's going to do x minus h squared plus y minus k squared is equal to r squared. So that's the standard equation, standard form equation of a circle. Okay, so our hk is negative 2 and 7, so x minus negative 2 squared plus y minus 7 squared is equal to 2/5 squared. Go ahead and simplify that, so that's x plus 2 quantity squared plus y minus 7 quantity squared. That's going to be equal to 4 over 25. So we'll go ahead and then try to do a little graph of this. So we have negative 2 and positive 7 as our center. Okay, and we have a really tiny circle. The circle is of radius 2/5, so that's going to be less than a half, and so I'm just going to try to guesstimate a little bit around there. And so there's our circle roughly. If we wanted to do a better sketch, maybe change the scale or something like that, but we're just going to leave it at that. Okay. Let's look at a little bit more here. So we're going to identify the center and radius of the circle with equations. So this time they come up with the equation x minus 5 squared plus y plus 4 squared is equal to 81. So the standard form of equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. So we have x minus 5 quantity squared and then y minus negative 4 quantity squared is equal to 9 squared. So we got it all matched up there, perfect. So our center is going to be the h and k, so that's going to be 5 and negative 4, and the radius is 9. Okay. Alrighty, I think we got one more little example to do, so let's go look to see what we got going on here. Okay, this time they say identify the center and the radius of the circle with the graph there. Okay, and so what I'm going to try to do is find like the longest distance across the circle like this and like this, and that's going to give us the diameter. The diameter is going to be the longest distance across the circle like this, informally. Okay, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So the diameter is equal to 8. But we don't need the diameter in our formula, we want the radius. Well, the radius is half of the diameter. And so the radius is equal to 8. Sorry, it's not equal to 8, it's equal to 4. Sorry about that. Half of 8 is 4, so half of the 8 is equal to 4. Okay, now we're going to count the across horizontally, and so I've already started it. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that seems to be correct. Our diameter is 8. Now where those two lines intersect, it's going to give us our center. And that is going to be at -4 and -4. So our center is at -4 and -4. So our equation is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So it's going to be x minus -4 quantity squared plus y minus -4 quantity squared. And that's going to be equal to, it should be 4 squared. 4 squared. Okay. So we get x plus 4 squared plus y plus 4 squared, and that should be equal to 16. Okay. Alrighty, so that completes this video. Stay tuned. I think we have one more video for circles where we'll be looking at coming up with the equation of the circle. Given some, we're going to be given an equation that's not in standard form. We're going to put it in standard form. We're going to be doing a little bit of light completing the square. So we'll see you on the next video.